So, we are going to proceed to assemble this LCD display clock based on Arduino. We have the main components here. This is the LCD display. This is the RTC chip. It's a chip that keeps the timing real precise. We have the Arduino Uno board, and we have the breadboard, in which, for the sake of simplicity in the video, I have already installed some jumper wires. And this is the potentiometer, which we can turn in order to regulate the brightness of this LCD display. So, in the left part of the breadboard, we can see that we have the power supply jumper wires. The red one is going to go to the 5-volt pin in the Arduino, while the black one is going to go to the ground pin in the Arduino. And all these jumper wires here, the black ones, are going to go to the ground pins of either the RTC or the LCD, while the red ones are going to go to the positive power supply, the active one, so the 5 volts. Alright, well, first of all, what I have done is, with this soldering machine and with this solder wire tin, I have soldered this comb to the pins of the LCD so that it's easier to work with, right? Alright, and I have already prepared the connections here. These two are going to the power supply. These other two are also going to the power supply in order to set the backlight. So 5 volts corresponds to the brightest light in the display, and the other one corresponds to the dimmest, so no light at all in the display. This one, this pin that corresponds to the V0 in the LCD, is going to the middle pin of the potentiometer, so that we can regulate the brightness of the display. And then all the other wires, which are going to be connected to the LCD, end up, or will end up, going to these digital pins in the Arduino Uno. These are the register select, the read write, the enable, some data pins, not all of them, and well, that's basically it. So without further ado, we can just connect it here. This is really easy thanks to the breadboard. We make sure it's well connected. Alright. Well, the next step would be to work with the real-time clock chip. This is a DS3231, really popular, really precise. And if we want to, it's not the case, but if we wanted to, we can add a little battery here, so that even when this circuit is unplugged from the computer, it will continue to work and to keep really precise time. We must be careful because this is designed for a rechargeable battery, so we cannot use a normal battery, it might explode on us. Okay, the pins that we are going to be working with here are ground, which is going to be connected as all of the black jumper wires to the ground of the Arduino, 0 volts. We have VCC, which is going to be connected to the 5 volts. And we have the classical I2C, inter-integrated circuit serial ports, so serial clock and serial data analyzer, SCL and SDA, which are going to be connected to the pins of the same name in the Arduino, which are just here. The first one is LCL, the second one is SDA. Alright, so we'll just place it whenever or whatever we have some space in the breadboard. There, for example, we connect the negative to the ground, the positive to the positive, and then with these two extra jumper wires I have here, we're going to connect serial clock to serial clock and serial data analyzer to, obviously, serial data analyzer. Alright, we are left to connect these pins, which are the data pins of the LCD to the Arduino. We can start basically at any digital pin. We have decided to start in number 7. So we just connect all of these pins in order to the Arduino digital pins. Then in the software that we will upload in the code, we have to specify which pin goes where. Okay, so pins 7 through 12 have been connected. The only thing that remains is connecting the power supply. Black jumper wire to ground, red jumper wire to 5 volts. Okay, everything seems to be ready. We can connect the Arduino to the computer. Immediately we can see that the LCD display has lit up, and alright, we can regulate the brightness, and we can see that while the date is correct, the time is not, because it has the code that I have uploaded some minutes or hours ago. So we can update it here. We go to Arduino, we go to the code, and we set the right time. Alright, so it is 2 o'clock, and we press upload. Alright, now it's done, and we can perfectly see that everything's working properly, and the time is 2 o'clock, the date is the 8th of June, and the seconds are working.